problem just goes wrong from there. So the first of them is the angle of elevation, and that's if you're standing on the ground and you're looking up at something, the angle that you're looking up at is your angle of elevation. So it says the angle through which the eye moves up from the horizontal, that means like from the ground, looking up. So I like to think about if I'm standing here and there's a building, or I don't even know. Technically we should measure from our eye, but we're going to measure from here. Right here would be your angle of elevation. Which throws people off, because I think it should be coming up from the top, but it actually is coming from the bottom. Or technically from his eyes, but he's not standing below ground, so. So far, in the first half of chapter 4, this was the only type of problem that we saw, angles of elevation. But today you're going to see also the opposite of this, which is an angle of depression. And the angle of depression comes from if you're looking down at something. So if you're standing at the top of a tower, or you're standing on the top of a mountain, I think we have some today standing in a lighthouse looking down. And so the angle of depression is the angle from which the eye moves down from the horizontal. So again, I can do some great artwork here. That if I'm standing up at something, I'm just going to draw a line here for saying I'm up on top of something. The angle of depression is the angle that I'm looking down at. So this right here would be my angle of depression. And again, it says the eye, but I always say we're really measuring from the ground. So as we do these problems today, those are kind of some keywords that we're going to look at. These are story problems, which means as you're doing the notes here, you don't really have to write out all the details. You're welcome to if you want. But if it was me, I would just kind of write out the meat of the problem here. And I think I have 3 problems that we're going to do, and that's it. So, everybody okay with this? Elevation from the ground up, depression, up looking down. So, here's my first one. An amateur radio operator, like I wouldn't write that down. I would write this on my paper. There's a 75-foot tower. I couldn't really find a good tower, so mine looked like some Egyptian tower or something. I don't know. I want to find the angle of elevation. Like maybe you probably want to write this sentence down. Find the angle of elevation to the top of the tower at a point on level ground 50 feet from the base. So, I don't know. I feel like that whole sentence is kind of important. And if you can draw your picture correctly, then it's all just about setting up the right trig function to solve for what's missing. And so that's why drawing the picture, I think, is the most important part. Because we've been doing sine, cosine, tangent for so long, I feel like that you're probably going to be pretty good at setting these problems up. And then you just get to use your calculators. So we have 75 and 50. Those are the numbers that we should be using. We just want to make sure that we put them in the right spot. So I would draw some sort of little tower or triangle or whatever you want to say. The tower is 75 feet, right? So do you agree that I could say that my lovely tower here, I could say this is 75 feet? I want to find the angle of elevation to the top of the tower from a point on level ground 50 feet from the base. So 50 feet from the base, am I measuring from down here, or am I measuring from here 50 feet? From the base, right? It says from the base. So from the bottom, I'm going to measure over, and it doesn't really have to be the scale, but I can say this is 50 feet. And I'm trying to find the angle of elevation, which remember is always coming from the bottom looking up, which means I'm looking for that angle right there. And then it's just figuring out which trig function that I want to use and making sure I type in the right button on my calculator. If I want to find this angle and I know this side and this side, which trig function do you think makes the most sense to use? Tangent is opposite over adjacent, and so I could say equals opposite, which is 75, over adjacent, which is 50. And if you can't stand it, you can simplify it, but there's no need to simplify it because your calculator is going to help you get the right answer. But it's really important that you know what button we're hitting on our calculator. If I want to solve for theta, am I going to use the tangent button? No, if I'm solving for an angle, what button am I going to use? Inverse tangent. That's the only time you use inverse tangent is if you're trying to get an angle out of that. So you're going to hit on your calculator inverse tangent of 75 over 50. And for the most part, story problems are always in degrees. So you want to make sure you're in degree mode on your calculator. Like in math class, we always use radians. In calculus, we use radians, but when we're talking about measuring angles of elevation, it kind of makes more sense to use degrees. And so I would recommend getting a calculator if you don't have one and checking that you're getting the right answer here. In degree mode, if I go to 2 decimal places, I got 56.31 degrees. Did you get that? I don't know. I'm just going to, but on your test, I promise it'll always say. And if it doesn't say, then I can't mark it wrong if you round differently than me. Questions about that? I feel like this isn't so bad, right? Well, let's look at an angle of depression problem, and then maybe look at one that's a little bit tougher, and then we'll be done. Oh my goodness, look at this one. I should have printed these out for you, huh, Logan? The angle of depression from the top of the Smoketown Lighthouse, 120 feet above the surface of the water, to a buoy is 10 degrees. I definitely don't need to know that it's a Smoketown Lighthouse. But the angle of depression is 10 degrees. Like you probably could, here's how I could shorten this up a little bit maybe. Angle of depression, 10 degrees. Lighthouse, 120 feet above the water. How far is buoy? Oh, so maybe we should write angle of depression 10 degrees to the buoy. How far is buoy? There you go. That's about as short as I can get it if I'm summarizing that. Yeah, mine's usually just like a trapezoid. This is how mine looks on my paper. It's like a TP. I don't even know what it is. It's terrible. I failed art. Just kidding. I didn't take art, so I wouldn't fail it. Again, you want to write, you want to get your important information, you want to label it in the right spot. And so I want to make sure that we talk about angle of depression because we haven't done those yet. 120 feet above the surface of the water. Do you agree that's how tall the lighthouse is? So I could write this as 120 feet. The angle of depression to a buoy. There's a buoy out here somewhere, and I don't even know. I'm just going to draw a little rectangle to represent my buoy. Here's my buoy out here. The angle of depression coming down here, and this is where it's kind of tricky. The angle of depression is measured from the horizontal at the top. So the really easy mistake to make is that you want to plug in 10 right here, but that's not 10. The angle of depression comes from measuring from the horizontal distance that you can kind of draw out. This is 10 degrees, not this. All right, so be really careful when you're labeling your angle of depression. You have lots of options here on how to solve this. It's just whatever way you see it and whatever way that makes sense to you. One thing I could do is I could kind of flip my triangle over. If this is my 10 degrees, could I draw the line in straight down to here, and do I know what this distance is? should be the same distance over here. Like this should be 120 feet also, which means you could still set up your triangle. What are some other options? If I know this is not drawn to scale at all, but if this is 10 degrees, should I know what this is? Because that should make a right angle, right? Because it's coming down from that lighthouse. Which means you also could use this angle. Because that should be 80 degrees. What else could you do? Way back in geometry class, which I know it's been a while, remember that whole thing about alternate interior, alternate exterior angles? I have this lovely line cutting through here, and this is 10 degrees. You know what this is down here? Also 10 degrees. So I just wanted to show you that there's lots of ways to set this problem up, and you're going to get the same answer either way. It's just making sure that you are following the rules here of geometry, really. So you could use this angle and this side. You could flip this down here and say that this is also going to be 10 degrees. You could use 80 degrees. Like, it's all going to work. So whatever you want to do. If we use the 10-degree angle, either one, what am I trying to find? How far the buoy is from the lighthouse. So I'm trying to find this distance, which I could just call x. If I'm using that top triangle, just like the lighthouse flips over, do you agree that this distance up here is going to be the same as that distance down there? So again, I'm kind of just flipping that triangle over. And so then again, you want to look at what you have. We have this angle, this side, and we're looking for this side. So which trig function you want to use? Yeah, I think tangent would work well again. I would have tangent of the angle, which is 10 degrees, equals opposite over adjacent, which would be 120 over x. I'm not going to use the inverse button on my calculator this time because I'm not solving for the angle. But I do have to maybe do some algebra here because the x is in the bottom, not the top. So do you agree that I can multiply both sides by x, and that would move the x out of the bottom? And then to solve for x, could I divide by tangent of 10 degrees? Or maybe after you do a few of these, you realize that when the x is in the bottom, you're always just going to divide that over because you flip that over. And you should be able to type that in your calculator and get an answer. Again, you want to make sure your answer is somewhat reasonable on this. My picture is not drawn to scale, so you don't want to just go by the picture. But I think it's a pretty big number. What did I get here? I got 680.55 feet. And if I would have drawn my picture better, 10 degrees is a really small angle, which means the other angle is going to be much bigger. But I didn't. Like, the picture doesn't really matter, as long as you get it set up right. How do you feel about that? Angle of depression. Just make sure you don't label in the wrong spot. That's the big thing. I got one more just to throw in. What if I gave you two different things in the same picture? It's about lighthouses too, but this is my last example. An observer in a lighthouse 350 feet above sea level observes two ships directly offshore. The angle of depression to the ships are 4 degrees and 6.5 degrees. How far apart are the ships? Now you have to draw a lighthouse and a boat. A ship, but I just drew a boat. I didn't draw a lighthouse. ship. Did you draw your ship yet? What about that ship that's just like stuck out in the middle of the ocean with like 4,000 people on it and they have yeah, and they have no like no electricity and no running water, and so they just have to go to the bathroom in plastic bags and set it outside their door for someone to pick up. And they have a food shortage, and they're just getting towed in like very slowly because their boat just died. Isn't that it's Carnival Cruises? Terrible. 4,000 people going to the bathroom in plastic bags. Like, really sounds disgusting to me. I hope so. Oh, and no air conditioning. Yeah. But you would think there's a lot of food on that ship. Like, I don't know. I'm kind of shocked with the food shortage, but. Buying more food, I guess. It's terrible. It's disgusting. It's pretty gross. The big thing on this one, I think, is figuring out which ship gets which angle, right? So I'm going to draw my horizontal like this, and I'm going to draw a line down to both of those ships. So I'm going to have a line to this ship. That's not. No, it doesn't really matter. I'm just drawing it to my boat. And again, this is not drawn to scale, but we should be able to figure out or think about which one of those should get the bigger angle because we're measuring from the horizontal down. So do you agree that this one is just going to be measured from here to here? But then this one, it would be measured from here all the way down to there? So which one of those is going to be the bigger angle? Yeah, the bottom one, even though when you draw it, it kind of looks smaller, but you're measuring from the top down. You're not measuring just that little, you're not measuring just this. You're measuring this whole thing. So that means this one should get the 6.5. And this one would just be 4 degrees. This one's also, you have to do a little extra work because they want us to find how far apart the ships are, which means they want us to find this distance in between them. But does that make a right triangle if I'm just looking at the distance in between them? Which means I think I need to find the distance from each one to the lighthouse like the last problem, and then maybe I could figure out the difference between them. So step 1 is I think I got to find the distance from the lighthouse to this boat, and I got to find the distance from the lighthouse all the way over to that boat. And again, we could do it just like the last one. If the lighthouse is 350 feet and I know those angles up there, could I draw in my upside down triangle and that would be 350 feet? This would be 350 feet. Do you like that way, or you want me to do it a different way? Because like the last one, I need that. If I'm using this angle, I need that right triangle. Or you could flip it down and you could make the angle down here. I can always do that. Like I always say, well, this is 6.5, then this is 6.5, and then I just use that. But since I did the last one like this, I'll stick with it. The bad part about this one is I have lines going everywhere. You know, I mean, that's round to 2 decimal places. Yeah. So if I stick with this one first, do you agree that that's my 6.5 angle? And I'm trying to find that distance again. Is it still tangent? I feel like we've done tangent in every single problem. It's still tangent. So for this distance would be tangent of 6.5 degrees equals 350 over x. And if I go over here, I'm going to call this a different letter just because I don't want to have 2 x's in my problem. But this one would be measuring this entire distance, right? So it's this great big triangle right here. Maybe I should do another color. This great big triangle right here. I'm going to call that distance y. but I still am going to do tangent, but it's going to be 4 degrees equals 350 over y. One thing you could tell if you did this right is that this should definitely be a bigger number than the 6.5 degree one. And just like the last time, if x is on the bottom, you're going to have to multiply it over and then divide it. So I think what you should be doing on your calculator is you would take 350 divided by tangent of 6.5 degrees, because you would have to divide that back over. And on this one, you would get 350 divided by tangent of 4 degrees. And they're pretty far apart. Like, the lighthouse is pretty far apart from those. I got 3,071.91 feet on that one, and 5,005.23 feet for the second one. Are you getting that, or close to getting that? So I got that equation. So I'm going from here to here, right? And I just flip that side over. So this is my other one. Right? But remember, that whole angle is just 6.5 degrees. So that's my angle, that's my opposite, that's my adjacent. Which is, again, why that one's kind of messy. Maybe I could have taken that and pulled it out for you. Other questions on where I'm getting that set up on that? So I've done a lot of work, but I haven't answered the question yet. I found how far each boat was from the lighthouse. How do I figure out how far apart they are from each other? Yeah, just subtract the two. So don't miss a point because you don't answer the question that's being asked. So make sure you pay attention to what's being asked on those problems. So to find actually how far apart they are, I'm just going to subtract those two. And I got 1,933.32 feet, something like that. Most of the ones on your homework are not bad. There's definitely a couple that are a little tricky that I'm sure that we'll talk about tomorrow. But just try them. Try to set up a picture and see where you can get on them. And there'll definitely be a few of these on your tests for this chapter. Questions about that? This is your last homework assignment besides your review. This is 4.8. We're only doing 1 day of this stuff. And I kind of just picked around and picked problems that I thought were okay to do. So make sure you write those down. Draw a picture if you need to. Most of them shouldn't be too bad to do. I do want to tell you that we're going to have a little quiz tomorrow, and I mean like a real quiz, not a homework quiz, because I want to see where we are on knowing our trig values and knowing our inverse trig values. So it's like a front side only quiz, but you need to make sure you know your unit circle. I have a thing up here on this next slide. There's going to be a couple of graphs, because we haven't really had a quiz yet to see where we are on this. Make sure we know how to do this. So I wrote this up here. You don't have to write this all down, but you're going to have a quiz tomorrow that's going to be no calculator. Most of the quiz, like all but 2 questions, are if you know your trig values from your unit circle or your triangles, and you know how to evaluate both regular trig functions and inverse trig functions, you're going to be good to go on this. It's kind of like a test to see if we know our values. Make sure you know the restricted ranges for the inverse trig functions. So like inverse sine and inverse tangent, what do you have to give me your answers in between? Negative pi halves and pi halves. And inverse cosine, what do you have to give in between? 4-7 day 1. Remember those first questions where you were just working them out? Like, what is the inverse tangent of 1? Or what is the inverse tangent of square root of 2 over 2? That's the kind of questions you're going to see. You're also going to see just questions like that were on our last quiz, or our last test. I'm just going to ask you stuff like, what is the sine of pi thirds? What is the sign of 7 pi force? Because if you draw your unit circle or use your triangles, we should be doing that. And there are 2 graphs on there, which means you might want to go back tonight and kind of look over those. Make sure you know how to find the period, if it's sine or cosine. Make sure to know how to find your asymptotes. It's not going to be a crazy tricky graph. I just want to know that you know how to graph these. But there's 2 of these, 2 questions. The rest is all just trig stuff, okay? But you don't want to leave the graphs blank. This way you can get some feedback before we have a test, and I can kind of see where we are before we start reviewing for our test next week. I think it's like a 20-point quiz, so it's not huge, but I hope it will be a quiz that helps people's grades, because we've had a few rough quizzes. But make sure you know this stuff. I'm not going to give you a pop quiz. I wanted to make sure I told you about it. Okay, so you have some time to work today to work on your homework. If you have questions about this stuff for the quiz tomorrow, I'd be happy to answer that as well. It doesn't say, I don't know, just go like 2 places.